Let's look at a problem on maximizing profit from the textbook. This is from their section 4.8. And what they give us is rather like what we've been dealing with, but a little different. C of x is 16,000 plus 500x minus 1.6x squared plus 0.004 x cubed. And so that's the cost as a function of production. Okay. Then it's a little different from what I gave. I gave x as a function of p. They're giving p as a function of x. And there's definitely reasons for that. I usually like thinking of p as the independent variable because that's the sticker, the price, the sticker on your box. But they're thinking of x as the independent variable. And so that's one difference is we'll use x, which is the production, and the sales. They're making that assumption as well, as the independent variable. If you wanted to, you could just put everything in terms of p, because we know a relationship between p and x anyway, but it's not essential. Okay, so now we just want to maximize profit. Okay, well, we'll get some interesting things out of that. The profit, big P, now we're going to think of it as a function of x here, a little different, is always the revenue. We're going to try and figure that out as a function of x minus the cost as a function of x. The revenue is the price. Here, that's thought of as a function of x. The difference between that and the way I like to do things is I would actually just have that be p because it's the independent variable. And then times x. Let me put in a little times to make sure. Minus c of x. Okay, so we had p times the sales, or x. Here it's the same thing, it's just we're thinking of it in terms of a different variable. Okay, so we can do that. Okay, here's p of x, and then multiply that by x, and then subtract off, and really big deal here, put this in parentheses. Okay, you're going to get a totally wrong answer unless you distribute the minus sign carefully. It's just a really unfortunate way of missing points here. So it's minus 16,000, that's from here, and then minus 1,700x and another minus 500, so minus 2,200x, and then minus 7x squared, and then plus 1.6x squared, so minus 5.4, oops, x squared, and then minus 0.004 x cubed. One thing note is that this cost function is cubic. That's to give it a kind of characteristic S-curve shape that you'll see in a lot of the problems in the book, and that in fact I built into the data in our memo. That it gives a fairly plausible, somewhat nonlinear, interesting shape to the cost function. Okay, so there's our profit as a function of x, and now we just need to take the derivative. Okay. Now I want to observe two things, well, at least one thing besides just the formula. We can just go ahead and take this and take the derivative. But I want to go back to here, because the book makes a very good point here. If I just take the derivative of both sides of this equation, I get that the marginal profit is the marginal revenue. That's how much additional money you get in for every additional bit of production in this case, minus the marginal cost. That's how much more it costs you. And remember, what we're trying to do is we're trying to find where that's equal to 0. Now, just making that 0 doesn't guarantee it's a maximum. But that's the first step, of course. And that's interesting. That says that r prime of x is going to be equal to c prime of x to achieve a max profit. It's not a sufficient condition. It's not everything you need, but it's certainly necessary. And that's kind of neat, because very often in an economic analysis like this, you might have a graph of r of x separately and c of x separately. So, for example, let's do that. Let me copy this down and just graph that thing. And it really shouldn't take that long, but it does. Let's see. Now we need a domain that's better. This is a parabola. It shouldn't look like a straight line. Well, that's because I don't have a domain that's big enough. So let's just take it out. Let's maybe take, we don't need 0. We don't need negative, because we can't produce a negative number of things. Okay, so there we go. Oh, let's even take it a little further. I thought 200 would be enough, but not really. Let's do 300. That should be enough. Okay, so here's a plot. Okay, So our revenue starts at 0 if we don't produce anything. It maxes out if we're producing a certain amount, and then if we produce too much, in order to move the product, in order to sell it, we've got to take the price down. That's this P of X function. 1700 minus 7x indicates a decreasing function. Price is a decreasing function of production. And so here's where I actually have to give them away. I'm not getting any revenue at all. Okay. Now on the same graph, I'm going to go ahead and graph the cost function. Just add in that item. And so here's the revenue and the cost together. Now remember, revenue minus cost, we can read that off this picture. Here's the revenue, this parabola. Here's the cost. It's kind of linear. Oh, sorry, it's sort of close to linear, but you can see that it's a little bit wavy because of the cubic. Here's a place where revenue equals cost, 0 profit. Here's another place where revenue equals cost, 0 profit. So notice we don't even want to get close to 0 revenue because the we still have to have a huge cost to make all that stuff. So this would be terrible, terrible. Even this isn't bad because it's 0 profit. What we're looking at is for where the difference between these is biggest. The gap between revenue and cost is the biggest. And the claim is that that's where the slopes are equal. So if we could find a place where the tangent line to this and the tangent line to this are parallel, we'll be able to find something that's biggest. Notice here, the tangent lines are anything but parallel. They're converging. Here, the tangent lines are not parallel because they're diverging. It's where they're going up by the same rate that they're kind of just keeping pace with each other and are about to start converging back together. So that's the graphical explanation of that. So we don't absolutely need that, but it's a really nice fundamental economic fact that marginal revenue equals marginal cost is a necessary thing to achieve the maximum profit. Now let's go back here and just maybe stick in here. Of course, we can always just take the derivative of this. We get minus 2200 minus 10.8x minus 0.012x squared, because it's a 3 coming in there. And we're just going to set that equal to 0. And that's where we would just need quadratic formula or numerical solve. Oops. I didn't want to evaluate. I wanted to solve. Sorry. Solve. Numeric. Okay. And something was wrong there. I'm getting negative solutions. That's not good. There should be at least one of these solutions that's positive. So I have to see, let's see, minus minus 7x squared I think that's not good. There we go. Hopefully you saw that. 1700 minus 500, that's plus 1200. There we go. Okay, so that's a plus 12. Okay. So, good example of error checking. Not a good example of doing arithmetic correctly, but a good example of error checking. Oh, not integer. What the heck am I talking about? Now I'm all flustered. Oh, darn. Here we go. If you've got a mistake, you've got to just always check the reasonableness of your solutions. Don't just put down and say, "Oh, I think the best is to sell negative amounts." Aha. So in fact, it turns out that they actually made this so it would factor. You don't actually even need the quadratic formula if you just take out a common factor. I think you just divide everything by 0.012. So 100 or minus 1,000. And so the claim is that if x equals 100, here, that's where these slopes are parallel. Therefore, the actual graph of the profit is going to be maximized. Let's actually go ahead and graph the profit too. We might as well. We're just going to add that in. And so our profit should appear to be maximized. Yeah, see, here's the profit. That's maximized exactly when this gap is biggest, and that's when x equals 100. And I was talking about, the lesson, of course, again, is I was talking about be careful with your signs, and then I bobbled a sign right here. 1700 minus 500 is plus 1200, not minus 2200. But now it's all fixed. Okay.